Good morning, students. Welcome back to the session. Today I am going to solve exercise 7.1. Exercise 7.1 in that fifth sum. Fifth sum. If L is the line L is the bisector of angle A and B is any point, BP and BQ are perpendiculars from B to the arms of angle A, show that triangle APB congruent to triangle AQB, BP equals to BQ or B is equidistant from the arms of angle A. Here one angle is given and this is the bisector for that. So A, this point is P and this is B and this one is A, Q. So this is a L. Now this L is the bisector of angle A. It means these two angles are equal. You have to show that triangle APB congruent to triangle AQB. How will prove that these two triangles are congruent? To prove that triangle APB congruent to triangle AQB and BP equals to BQ. Now prove this one. You have to take two triangles. So in triangle APB and AQB, triangle AQB. In these two triangles, these angles are equal. So these two angles are equal. So A, this is QAB is equal to angle BAP. So these two are the equal angles because this is the bisector. Line L is the bisector of angle A. And angle P is equal to angle Q, which is the perpendicular. So perpendiculars. So these two angles are equal. When the two angles are equal, then the third angle also will be equal, right? So now AB is the common side. AB is the common side so that by AA congruence rule, triangle APB congruent to triangle AQB. That is angle side rule. By AA, yes, these two triangles are congruent. Now, when the two triangles are congruent, then their corresponding parts are equal. So what are the corresponding parts? That is AP will be equal to AQ and BP will be equals to BQ. Therefore, PB, that is BP equals to BQ, which is the corresponding parts of congruent triangles. So both are equal. Yes. Now, second question number 6. In question number 6, in the figure AC equals to AE. This is given. So question number 6, it is given that AC equals to AE, AB equals to AD and angle BAD is equal to angle EAC. You have to prove BC equals to DE. You have to show that BC equals to DE. And the figure given is, see here, this is one triangle here and one more triangle here. So A, B, C, D, E. Now see here, AC equals to AE and AB equals to AD. So in this figure, these two sides are equal and these two sides are equal. How we can prove this? Now, in triangle in triangle ABC and ACE. ABC and ADE. In these two triangles, AB is equal to AD. AD of this triangle. Then AC of this triangle is equal to AE of the triangle ACE. So in these two triangles, so this triangle, see here, ABC. The other triangle is this one. That is AE, then AED. Now in these two triangles, AB is equal to AD and AC is equal to CE. AC is equal to AE. So these two sides are equal. Now for both the triangles, this is the common. See here. So this part is common. So this angle is common. So what I do is, see here, DAC is the common angle for both the triangle. And here one condition is given, BAD is equal to EAC. Now add angle DAC on both the sides. If you add DAC on both the sides, what you will get? Angle BAD plus angle DAC is equal to angle EAC plus DAC. When equals are added, then they are equals are E. So that DAC, now see here, BAD plus DAC equals to BAC. So angle BAC equals to EAC plus DAC, which is equal to DAE. It means that BAC, this angle is equal to DAE, this angle. It means that side angle side. So SAS rule, both the triangles are congruent. Triangle ABC is congruent to triangle A. Then B is equal to, so B is equal to DE. So SAS rule. When these two triangles are congruent, then their corresponding parts are equal. That is, BC is equal to DE. BC equals to DE. This is the CPCT. Okay. Thank you, students.